Hi everyone, and welcome to exercise 2 on page 58 of the workbook. Let's take a minute just to read this question together. So, a camera filming a rocket launch is positioned 500 meters from the launch pad. We can look at the diagram and kind of see the situation over here. To keep the rocket in view, the camera operator must steadily rotate her camera upward so that the angle of elevation of the camera is given by, and then we've got a formula, theta of h equals 180 over pi times the arctangent of 0.002 h degrees, okay, where h represents the height of the rocket in meters. And they would like us to find the derivative of this function theta at 100. Okay, so before we get into the details of taking that derivative, let's go back to the picture over here to the right for a minute. Okay, so we've got the rocket sitting here, and that's rising. And notice that as the rocket goes up, this angle, okay, between the ground and kind of the line of sight up to the rocket, that angle is going to get bigger the higher the rocket goes. Okay, so we're trying to calculate the derivative of that angle essentially, which is telling us how fast that angle is increasing. All right, so let's see if we can do that. Find a formula for the derivative just to get us started. So theta prime of h means that we're going to be taking the derivative of this function that they gave us. Notice first that 180 over pi, that is a constant. Okay, so we can just factor that constant to the side and worry about taking the derivative of the arctangent of 0.002 h part of this. Okay, so we need to ask ourselves then, what derivative formula would apply? Let's first just write the part that we're trying to take the derivative of. Okay, so the derivative of arctangent of 0.002 h. Okay, well notice that that's a chain rule situation. We've got arctangent of an inside function, so we can call that u. And then the question is, how do you take the derivative of arctangent of u? Okay, well, you can scroll back a couple of pages and find the formula. The derivative of arctangent of x is 1 over 1 plus x squared. So in our case, we're going to get 1 over 1 plus u squared. And then the second part of the chain rule is to multiply by the derivative of the u, okay, which is 0.002 h in this case. All right, so let's rewrite the parts that we're done with here. 180 over pi, 1 over 1 plus 0.002 h squared. And then the derivative of 0.002 h, that's just going to be 0.002, okay, because the derivative of the h is 1. Okay, so there's a formula for our derivative. Next step is to calculate the derivative of the number that they asked us to. They want us to find theta prime of 100. All right, so that just means we're going to take 100 and substitute it in for h everywhere. Okay. Now, what do you get if you substitute h equals 100 in here? You're going to get 0.002 times 100, and if you do that multiplication, you actually get 0.2. Okay, that's what ends up being squared. Okay, times a 0.002 at the very end. All right, and now this is a job for your calculator. If you grind all of that out and get a decimal approximation, that comes out to be about 0.110. Okay, now notice there's an important second part to this problem. They would like us to interpret our answer in the context of this problem. What does this number mean that we just calculated? Okay, well, I generally like to start by thinking about units to answer a question like that. So what are the units of the derivative? We can answer that question by thinking of what a graph of theta of h would look like. Okay, so if you go up to the very top of the page here, theta of h, we had an input variable of h and an output variable of theta. What are the units of those two variables? So what is h being measured in? Well, h was a height. Okay, if you look back at the picture, the height of the rocket in meters. And theta was an angle. They told us that its units were degrees in the problem. Okay, so what should the units of a derivative be? Well, derivatives are about slopes again, so the units of that derivative should be degrees per meter rise over run. Okay, those units give us a clue as to what this derivative is really measuring. It's measuring the rate of change of an angle with respect to a height. That's the degrees per meter that we're seeing here. All right, so let's see if we can put that into words and explain this statement. Okay, so this means that, and we might start by explaining the meaning of that 100. That's giving us sort of a starting height. So when the altitude of the rocket is 100 meters, we're getting this rate of change. Okay, so that 0.110 degrees per meter is telling us that the camera operator must rotate the camera upward about 0.110 degrees for each meter of altitude that the rocket gains. Okay, and you can kind of notice in the last part of our explanation those units. Degrees for each meter, that matches the degrees per meter up here that we noticed when we figured out our units.